Hello everyone. In this video, let us see relation between real depth and apparent depth of a tank. A water tank appears shallower, that is, less deep than what it actually is. This is on account of refraction of light. To prove this, let us take this adjacent figure. Suppose O is a point object at an actual depth OA below the free surface of water. XY is a tank. So let us consider this as water, this as air, and here XY is interface. A ray of light incident on XY, that is interface, normally along OA, passes straight along OAA prime. Another ray of light from O incident at an angle I on interface XY along OB deviates away from the normal because light is traveling from water to air, that is denser medium to rarer medium. So when light travels from denser to rarer medium, light ray deviates away from normal. It is refracted at angle R along BC. On producing back, BC meets at I on OA. Therefore, I is virtual image of O. That is, when seen through water, O appears at I. Therefore, apparent depth is AI, that is represented by Y, and real depth is OA, that is represented by X, which is less than real depth. Here apparent depth is less than real depth. Okay, so now let us consider angles. Angle AOB. AOB is equals to angle OBN. So here it is O, here it is B, and here it is N prime is equals to I. So these are alternate angles I and I. Okay, so then I can write angle AIB is equals to angle NBC is equals to R. What is that? AIB and NB and C. These two angles are corresponding angles. Okay, so then I can write in triangle OAB. Let us consider the triangle OAB, right? Then I can write sine I. Here we have angle sine I, that is equals to opposite side by hypotenuse. So what is opposite side for this triangle OAB? Opposite side is angle is here. Opposite to this angle is AB. Then I can write AB upon hypotenuse is what? OB. OB. In the same way, let us take another right angle triangle. In triangle IAB. IAB. Angle is here R. AB is opposite side, right? And IB is hypotenuse. Then I can write it as sine R is equals to AB upon IB. Okay, as light is traveling light is traveling from denser medium, that is water, to rarer medium, that is air. From water, which can be called as here denser medium, to air, which is rarer medium. Okay, then we can write this as, using Snell's law, we can write it as refractive index of water with respect to air, that is equals to sine R by sine I. I can write this as sine R upon sine I. Okay, if I represent this as expression 1, this as expression 2, here sine R is nothing but AB by IB and sine I is nothing but AB by OB. So this can be written as AB upon IB divided by AB upon OB. Okay, so which can be written as, this is equals to AB upon IB into OB upon AB. Okay, so from this I can cancel here AB and AB. So I can write this relation as mu refractive index of water with respect to air is equals to OB upon IB. Okay, OB upon IB. Let us consider these angles are small. When angles are small, B is close to A. So we can see this point in ray diagram. This is B. Angles are small, then this B will be close to A. When this B is close to A, OB will become OA and IB will become IA. Okay, so then we can write this relation as refractive index of water with respect to air is equals to, B can be written as A, as the points are closer, as the angles are small. I can write OA upon IA. So in ray diagram, OA is what? Real depth, that is represented as X, and IA is apparent depth, that is represented as Y. Then we can write this relation as refractive index of water with respect to air is equals to, OA is nothing but real depth upon IA is nothing but apparent depth. So here real depth is represented with the letter X, apparent depth is represented with the letter Y. Okay, if we are about to find apparent depth, then take apparent depth subject and transpose this refractive index of water with respect to air in denominator. Then I can write this as Y is equals to real depth X upon refractive index of water with respect to air. So this is a relation between apparent depth, real depth and refractive index of a given medium, that is denser medium, with respect to rarer medium. Let us see an expression for normal shift. So here normal shift is equals to normal shift is equals to real depth minus apparent depth. Okay, so just now we got an expression for apparent depth. Apparent depth is equals to real depth upon refractive index of water with respect to air. If I substitute this here, then I can write this as real depth minus, what is x here? Real depth upon refractive index of water with respect to air. Let us take real depth common. Then I can write this as real depth of 1 minus 1 upon refractive index of water with respect to air. So if I write refractive index of water with respect to air as mu w upon mu a, then I can write this as real depth of 1 minus 1 upon refractive index of water with respect to refractive index of air. So this fraction is in denominator. Then we can write this relation as real depth of 1 minus, so this is 1 upon mu w upon mu a. So as fraction is in denominator, this mu a will go to numerator. Then I can write this as mu a, refractive index of air, upon refractive index of water. So this is a relation of what? Normal shift. Right? So this is one relation of normal shift. That is real depth into 1 minus 1 upon refractive index of water with respect to air. This is one relation for normal shift. Real depth into 1 minus 1 upon refractive index of water with respect to air. This is another relation for normal shift, that is real depth into 1 minus refractive index of air upon water when we simplify this. Hope you have understood the explanation. Thank you.